There are 3 germ layers that create the epiblast of the inner cell mass inside of a blastocyst. There is the ectoderm, the mesoderm, and the endoderm. The endoderm will become glands, the respiratory and GI systems. The mesoderm will become smooth muscle, connective tissues, the reproductive, the skeletal, and the cardiovascular systems. And the ectoderm will become the central nervous system, the peripheral nervous system, the skin, and the eyes. The middle section of the ectoderm will begin to thicken, and it is called the neural plate. In the center of the neural plate will become a neural groove. The neural groove will begin to dive inwards into where the mesoderm is underneath the ectoderm, creating 2 neural folds on each side. At the top of each neural fold, the neural crest, will become neural crest cells once this ectoderm fully closes in on itself. This ectoderm will eventually pinch off at the top, closing off, creating the neural tube. The ectoderm above the neural tube will close itself off. That crest in the center will become the crest cells, the neurocrest cells. And once the neural tube is fully developed, primary neurolation has been achieved. It'll look fully like this, with the ectoderm on the top, those neural crest cells in the center, with the neural tube right in the center of the mesoderm, and the endoderm right here at the bottom. Through development, the neural tube will continue to elongate. The rostral end will close, while the caudal end will elongate into the spinal cord. The caudal end will widen and turn into the 3 primary vesicles. The prosencephalon, which will become the forebrain, or the cerebrum. The mesencephalon, which will become the midbrain, or the brainstem, and the rhombencephalon will become the rest of the brainstem, the pons and medulla, and the cerebellum, while the caudal end will elongate and become the spinal cord. Once the spinal cord is developed, secondary neurolation has been achieved. There are 2 flexures in the neural tube, one between the rhombencephalon and the spinal cord, called the cervical flexure. This one will straighten out later in development. And the cephalic flexure, which will persist into adulthood, and it'll stay at a 90-degree angle between the forebrain and the brainstem.